All right, let's dive into one of the oldest, deepest questions out there. A question that really challenges everything we think we know about reality itself. So here's the big idea. Is the world we describe, our map, the same thing as the world that actually is, the territory? Or, and this is the really tricky part, do the very tools we use to make that map actually change what we're able to see? We're going to tackle this puzzle from three really fascinating angles: mathematics, quantum physics, and even metaphysics. Okay, first up, mathematics. For literally thousands of years, some of the smartest people on the planet have been arguing about one seemingly simple question. Did we invent math, or did we just discover it? And this debate, it splits some of the biggest names in history right down the middle. In one corner, you've got the Platonists. Think Kurt Gödel and Roger Penrose. For them, math is this objective reality that's just out there. We don't create it. We're more like explorers who stumble upon its truths, like finding a lost continent. Then in the other corner, you have the formalists, and this includes Albert Einstein, by the way. They'd say, nope, math is a human invention. It's like this incredibly sophisticated game we made up, with rules that we created. It's a powerful tool for sure, but not some external truth.
So you've got these two sides going at it for centuries. And honestly, there's no clear winner. But what if that's because it's the wrong question? What if the answer is a little more interesting than just a simple either-or?
This is where astrophysicist Mario Livio comes in with a really brilliant idea. He suggests, look, maybe it's both. Maybe it's a two-step process. Step one, we invent. We look at the world around us and we pull out these abstract concepts, right? We see a bunch of apples and we invent the idea of number. We see the edge of a field and we invent the concept of a line. But then comes step two. We discover. Once we have these invented ideas, we start to find these incredibly deep, totally unexpected relationships between them. Relationships that feel like they were there waiting for us the whole time.
And check out these examples. They're just wild. Take knot theory. It literally started as this super abstract, almost pointless mathematical game. And now, it turns out to be absolutely crucial for something like string theory. Or how about number theory? For ages, it was considered the purest, most useless form of math, while now it's the engine behind all of modern cryptography. My favorite, though, is non-Euclidean geometry. In the 19th century, it was just a mathematical curiosity, a what-if game. Then Einstein comes along and discovers, whoa, this game is actually the perfect way to describe the fabric of our universe. It's like we invent a map for fun, and then we're totally shocked when we realize it's a perfect match for the real territory.
Okay, so let's shift gears now. We're leaving the clean, abstract world of math and diving headfirst into the seriously weird world of quantum physics. This is a place where just looking at something seems to change what you're looking at.
So, at the core of all this quantum weirdness is a concept called superposition. Basically, a tiny particle isn't in one specific spot. It's kind of everywhere and nowhere at once, existing as this blurry cloud of possibilities. That spinning coin analogy is perfect. While it's in the air, it's not heads, it's not tails. It's this weird mix of both possibilities at the same time. It's pure potential. So, what happens when we look, right? This is the million-dollar question in physics. It's called the measurement problem. What is it that makes that spinning coin finally land? What forces reality to just pick one? To go from that blurry cloud of maybe to a definite this the moment we try to measure it?
Well, there are two big theories. The first is called projective collapse. This is the idea that our act of measuring causes a real sudden collapse. The universe just randomly picks an outcome. Boom, and that's that. The spinning coin instantly lands. The other idea is decoherence. This one's a bit more subtle. It says the quantumness of the particle kind of leaks out into the environment around it. It gets tangled up with everything, and that interaction makes it look like it's settled down into one state. It's less of a sudden jolt and more like the spinning coin slowly settling because of the air and the table. But notice the theme here? In both scenarios, our attempt to map the system, to measure it, is completely tangled up with the territory we're trying to observe.
All right, for our last stop on this journey, we're going about as deep as you can possibly go. We're talking metaphysics. And now, we're not just questioning our description of things anymore. We're going to question the very idea of a thing in the first place. So think about this for a second. What's more fundamental? What's more real? You as an individual person? Or is it the unique pattern of qualities and relationships that defines you? Your height, your personality, your memories, your connections to others? Are we all just individual Lego bricks building the world, or is reality just one giant interconnected structure? To really wrap our heads around this, there's a fantastic thought experiment from the philosopher Theodore Sitter. Okay, so picture two worlds. World A is our world. In it, you've got Barack Obama, a 6'1" politician born in Hawaii, all the properties we know. And you've got Theodore Sitter, a 5'9" philosopher from a city known for cheesesteaks. Simple enough? Now imagine World B. From the outside, it looks exactly the same. Every atom is in the same place. Every relationship, every event is identical. There's just one tiny difference under the hood. The individual filling the politician role happens to be named Sitter, and the individual filling the philosopher role is named Obama. They've just swapped name tags, so to speak. And this brings us to a really mind-bending question. If the entire structure of the world is completely identical, is World B actually a different world? I mean, really? Sitter's point here is to challenge one of our most basic assumptions, that individuals are the fundamental building blocks of reality. What if they aren't? What if we're just placeholders, and the only thing that's truly real, the territory, is the pattern, the structure itself? Okay, let's pull back for a second. We've talked about math, quantum physics, and metaphysics. These seem like totally different fields, right? But as you've probably noticed, there is this one powerful underlying tension that connects all of them. It's the exact same problem, showing up in different disguises. In math, the question is, are we inventing the map or discovering the territory? In physics, it's, does our measurement create the map or just entangle us with the territory? And in metaphysics, it's even deeper. Is our map, made of individuals, even the right way to think about a territory that might just be pure structure? And it all points to one unavoidable conclusion. The map is not the territory. But it's more than that. The very tools we use to make our maps, whether it's mathematical concepts or scientific instruments or even philosophical ideas like individuals, these tools profoundly shape and maybe even limit the reality we're able to see. So that leaves us with one last big question to chew on. If every single map we make is inevitably shaped by the hands that draw it, can we ever hope to see the territory itself? Is it even possible to step outside of our own descriptions and see reality, as it truly is? Something to think about.